Okay, Algebra 2 students, this is a video for example 5 for section 2.5. We're going to write a quadratic equation in vertex form. We're going to use some of the skills that we've applied to completing the square. Let's say we want to write the equation y equals negative 2x squared plus 10x plus 1 in vertex form and then graph it. And what is the maximum or minimum value of the graph of the equation? First, we write the original equation. We're going to subtract 1 from each side to get y minus 1 equals negative 2x squared plus 10x. We're going to factor out a negative 2 out of this so that we can get x squared minus 5x. Now that we have x squared minus 5x, we're going to use this. We're going to focus on this part right here. And we're going to complete the square. It's going to be a little cumbersome here because half of negative 5 is 2.5, and 2.5 squared is 6.25. Okay. And because we factored out a negative 2, it's not just as simple to just add 6.25 on this side. It's really negative 2 times 6.25. So that's why they have added a negative 2 times 6.25 to this side. Okay. We could have just multiplied. What is that? That is 12.5. So it's minus 12.5. And you already have the minus 1. So minus 1 and minus 12.5 would be minus 13.5. Let's see if they wrote that. Yes, they did. Minus 13.5. And now we have equals negative 2. And we know this is a perfect square now. X minus 2.5 squared. Then we add the 13.5 back over to this side because the goal was to write it in vertex form. And now it is in vertex form. Negative 2 is the value for A. 2.5 is the value for H. 13.5 is the value for K. So we know it has a vertex at 2.5, 13.5. It's a negative 2 for A, so we know it opens downward. Opens downward. Has a maximum of y equals 13.5 because it opens downward. That happens at x equals 2.5. And then you can sketch it knowing those parts. Okay? So right in here was key to get to this spot here so we could do completing the square. Let's see how many problems they give us to practice that. They give us 2. Click pause and give it a shot and then come on back. Okay, we subtracted 7. Subtract 7 from both sides, so this ends up being y minus 7 equals the negative 3 x squared minus 9x. But then we're going to factor out the negative 3 and leave us with x squared. Now if I factor out a negative 3 out of this, I get positive 3x. Okay. Now this is what we wanted, so we can complete the square. Completing the square involves us taking half of 3, which is 1.5, and squaring it. 1.5 squared, I believe, well, I don't want to embarrass myself by getting it wrong, so 1.5 squared, 2.25. And now that's a perfect square. That will be, not that I'm going to do it yet, but I'm going to write it down before I forget. That is x plus 1.5 squared. Now, the rest of the equation was y minus 7 equals the negative 3. Now what we did is we just added this part here. So we need to take 2.25 times negative 3 and add it over to this side. So over on this side I really have y minus 7, and I also have minus 3 times 2.25 is 6.75. and that equals this squared over here. This is negative 13.75, so when I'm going to add that to both sides to get it into vertex form. I lost the 3. It should have been a minus 3 here. Okay, the negative 3 times the 2.25 gave us a negative 6.75. I had to subtract 6.75 to both sides. Minus 7 and minus 6.75 is minus 13.75, but I need to add that to both sides to bring it over here. Now, what was the equation? What was the question? I've run out of space, so let's see how much of this I can answer right now. Write the equation in vertex form. Done. Identify the maximum or minimum. Well, it's got a negative 3, so that means it opens down. That means 13.75 is its maximum, and that occurs when x equals negative 1.5, right, from this. The vertex is at negative 1.5, 13.75. And they want us to graph it. I think I'll skip the graph and just go to theirs since I've run out of space. I don't even know if are they going to graph it? No, they didn't graph it. But you should be able to graph it, especially what you learned earlier in this chapter on how to graph equations. All right, why don't you try this one? Click pause, try this one, and come on back. All right, we need to get the 9 over to the side, so y minus 9. And I'm going to factor out the 2 and get x squared plus 6x. And then I want to make this into a perfect square, so half of 6 is 3, and 3 squared is 9. So there's kind of like, I'm going to be adding 9 to this. But in order to do, and that's going to create x plus 3 squared. However, by fictitiously, I guess, adding a 9 to this to make it a perfect square, I've actually added 2 times 9, 18 to this side, so I need to add 18 to this side. So when I add 18 to this, I get y plus 9. And to get into vertex form, I have to subtract 9 from both sides to get the y by itself. So the equation is going to be y equals 2 x plus 3 squared and what was I doing? I subtracted 9 minus 9. So this has a let's see, it's got a positive 2, so it opens up. So it has a minimum at the vertex, which is at negative 3, negative 3, negative 9. That's where the vertex is. It's a minimum. What else would we have to identify? The axis of symmetry is at x equal negative 3. I forget what else they wanted us to figure out. Let me go back. Identify the maximum, minimum, set the equation in vertex form. So I think I did all those things. Let's see how close I was. 2 x plus 3 squared minus 9. The minimum is at negative 9 when x equals negative 3. All right. Your teacher should assign some of these problems. 43 through 48. Nope, 43 through 52. That's what that looks like for all that. That's it for this video. Have a great day.